Welcome back to Best Academy TV. In this series we're gonna focus on JAMB 2026 exposed questions. So this is question 2 here. Before we solve this question here, let's understand the question clearly. They said a 2 microfarad capacitor is connected directly across a 150 RMS 60 Hz AC source. A 2 microfarad capacitor is connected directly across a 150 RMS. The word RMS simply means root mean square. 60 Hz AC source. Calculate the RMS value of the current. These are the options given to us here. Now, before we solve this question here, class, solution first. Solution first, okay? Now we are asked to find the root mean square value of this AC circuit. So we have formulas we use to find the root mean square current. So whenever you are asked to find the root mean square current, we have two formulas. The first formula is this: the root mean square value is equal to the peak current over square root of 2 over square root of 2. Okay. Now this formula is only used when the peak current is given to you. You can use this formula here. But if peak current is not given to you, maybe voltage is given to you, the root mean square voltage is given to you, and the impedance is given to you, or resistance is given to you. The formula to use to find the root mean square current is this: that's root mean square voltage is equal to root mean square current times the resistance. Okay, this formula here is taken from Ohm's law. Please remember, okay? But there's something you have to understand here, that the position of this resistance changes depending on what is given to you in the AC circuit. If it is only resistance given to you in the AC circuit, it's going to be resistance. So if resistance is given to you in the AC circuit, capacitance is given to you in the AC circuit, inductance is given to you in the AC circuit, what you replace as your resistance will be the total resistance, and the total resistance is called impedance. Please take note. So whenever resistance is given to you only in the AC circuit, you will use this particular formula here. But if capacitance is given, or inductance is given, or both of them are given with resistance, you use impedance. Please take note. So what is an impedance here? The impedance is the total resistance in a circuit. Impedance is the total resistance in a circuit. Please take note. And what is the formula definition of impedance? The formula definition of impedance is Z is equal to square root of R square plus reactance inductance minus reactance capacitance all square. Please take note. So if this is not given, if resistance is not given, it means that resistance will be equal to 0. It is not given the equation. If reactance capacitor is not given, it means that reactance capacitance will be equal to 0. And again, if reactance inductance is not given, it means that it's equal to 0. Please take note. Depending, okay? When anyone that is not given, it means that invariably they are equal to 0 in that particular circuit. Please take note of this. So let's go back to the question to understand this. Of course, when you look into the question here, capacitor is given. That means we can easily calculate our reactance capacitance. Okay, and then no other thing that is given to us here. So how do we calculate our reactance capacitance. Our reactance capacitance is given to us as reactance capacitance C is equal to 1 over omega C, and omega relating to frequency is the as 2 pi f. Please take note. So when you replace this here in terms of frequency, you have this here. You have something like this. Sc is equal to 1 over 2 pi fc. Please take note. So we replace this to this because frequency is given to us, not angular frequency. But if angular frequency is given to you, this omega here, that is this W represent omega. And this omega is called angular frequency. But if only frequency is given to you, the formula relating omega with frequency is this formula here. So when you write this here, you have this particular formula here, okay? You have this particular formula here. So class, our capacitor is given to us as, sorry for this. So class, our capacitor is given to us as 2 microfarad. And this word micro here is a prefix in mathematics. And the value is times 10 raised to the power minus 6. So when you replace that, we have this to be 2 times 10 raised to the power minus 6 farad. Please take note. The frequency here is given to us as 60 hertz. The frequency here is given to us as 60 hertz. Please take note. And we are asked to calculate the root mean square. But remember that in this question here, we are asked to calculate the root mean square value of the current, okay? And the formula to use here is this formula here. Please take note. So remember, voltage is given to us in the equation. We are asked to calculate this one here, and resistance is not given to us, but there's something that stands as resistance. Remember, impedance stands as resistance. That is the total resistance. Reactance, inductance stands as resistance. Please take note. Okay. So what is given to us? Reactance, inductance also stands as resistance. Reactance, capacitor also stands as resistance. Please take note. So what is given to us here is capacitor, and from capacitor we can calculate reactance capacitor. So what will stand as a resistance in this equation is reactance capacitance. Please take note. So in place of this here, in place of root mean square voltage equal to root mean square current times reactance capacitor. Remember, impedance acts as a resistance. Arrow, which is resistance, also stands as a resistance, okay? Reactance, inductance also act as a resistance. But if you have 3 of them or 2 of them, the only formula to use, the only resistance to use is the total resistance, which is what? Impedance. Please take note. But if you have only one of them, either resistance, you can place resistance there. If you have only inductance, you can place inductance as the resistance there. If you have only capacitor, you can place reactance capacitor as the resistance. Please take note. But if you have 2 or 3 of them, you can place inductance as the resistance. Do you understand that? So now let's solve for reactance capacitance. That is this here. When you do that, we have something like that. We have something like this, sorry. When you do that, we have something like this. Okay, when you replace the value, we have reactance capacitance will be equal to class 1 over 2 times that pi is a constant value, that is 3.142 times the frequency given to us there is 60. You replace your 60, please take note. So when you punch your calculator class times multiply by 2 times 10 raised to the power minus 6. When you punch your calculator, our reactance capacitance will be equal to class 1 over 754.08 times 10 raised to the power of minus 6. So I will take this 10 raised to the power minus 6 to the numerator to make it to be positive. Remember, whenever you have something like this, 1 over s is the same as s raised to the power minus 1, meaning that whenever you are taking anything from denominator to numerator, the sign of the power will change. The same thing here. Whenever you are taking anything from numerator to denominator, the sign of the power will change. So taking this here, 10 raised to the power minus 6 from denominator to numerator, I will have the result to be this 10 raised to the power of 6 over 754.08. So 10 raised to the power of 6 is having it to be 0 into 6 places. So this will be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 over 754.08. Please take note. So point your calculator. Our reactance capacitance will be equal to class 1326.1192 in ohms. Please take note. It's a resistance. So let's come back to this. Remember, we are not asked to find the reactance capacitance. We are asked to find the root mean square current, and we have two formulas to solve for root mean square current. So since our peak voltage is not given to us, we won't use the first formula. Okay, we'll use the second formula, which is the Ohm's law formula. And this is the formula here, okay? Here's the formula to use. But there is something you have to understand in this formula here about resistance. That this resistance changes depending on the resistance given to us in the equation. So if resistance is only given to us in the equation, we use only resistance. But if capacitor is given to us, we use reactance capacitance as the resistance. If inductance is given to us in the equation, we use reactance inductance as the resistance. But if two or more is given to us, two or more of the resistance, either resistance, reactance capacitance, reactance inductance is known to us, we use what we call impedance. If two or more of them is given, we use impedance. So this is the formula to calculate impedance here. Please take note. So if resistance is not given, we say that resistance is equal to 0. So if inductance is not given, we say that it's equal to 0. If reactance inductance is not given, we say that it's equal to 0. Please take note, depending on the one that is not given to you there. But what is given to us here is capacitor. That means the resistance I will use will be reactance capacitance. Please take note of this, okay? So to calculate this, our resistance is going to be, reactance capacitance. That means the root mean square voltage is equal to the root mean square current times reactance capacitance. So let's replace. The root mean square voltage is given to us as 150 is equal to the root mean square current is what we are asked to calculate times the reactance capacitance is given to us as 1326.1192. So class, make the root mean square current the subject of formula. That means the root mean square current will be equal to plus 150 divided by 1326.1192. So when you point your calculator, I will have the answer as 0.1131 amp. Please take note of this, okay? So in our next video, I will show us the short way of solving this kind of question. All you have to do is to hit the subscriber button or the plus button, okay? Thank you.